in the office of the Always Believe House. And today today and tomorrow, we're going to do the statistics part of your Algebra 1. Oh, that's more power. Okay, so I'm going to start recording, and a magical whiteboard appears in the office. Oh, so we're about to start rocking and rolling. Notice this is the paper that you have for today. It's several pages. This will be good for 2 days, and we're not going to do some of the problems because they repeat. Okay? Now then, before we start, let's look at what we have to learn today. Okay, this is what you need to know from the state of Texas about what you're about to learn. Okay, tomorrow we will calculate the correlation coefficient. You don't know what that is, okay? So tomorrow we're going to use the calculator to calculate the correlation coefficient. That's going to tell us the strength of the scatter plot. Basically what we're studying today and tomorrow is scatter plots and if there's an association or not, okay? The next TEK, okay, is compare and contrast association and causation. You probably don't know what that is. You're going to know what that is, okay? So we're going to compare and contrast association and causation. And then write with and without technology linear functions that provide a reasonable fit to estimate solutions, okay, and make predictions. So we're going to use these scatter plots, generate a linear equation, and make predictions with it. So the three things you're going to get out of today and tomorrow, you're going to know what a correlation coefficient is. Tomorrow we will use the calculators. Make sure your calculator's ready, either the online version or the physical you need a TI-inspired calculator to do tomorrow's lesson. We're going to talk about association and causation. What is that? Okay, you're going to learn that. And then you will also learn how to predict with a table of values or a scatter plot. Oh, so that's what we are about to learn. Now then, let's go to today's lesson. Okay, and on this lesson right here, this is like the meat of it. What I did is I reprinted the reteach, okay, and this gives you the terminology. You have done scatter plots in junior high. So a scatter plot is just some trend dots, right, if they go up or down. A scatter plot is also called an association. That was one of those words, right? Okay, so an association is basically a table of X and Y values. Okay, so all those tables we've been doing, those are associations, okay? Now then, if you read through there, it talks about a scatter plot, and you've seen these in junior high. Then it talks about this. If the dots go up, it's a positive correlation. An example of a positive correlation would be scatter plots that do this, right? A negative correlation would be a scatter plot that would trend downward, right? Okay, so that scatter plot would trend downward, right? And then no correlation would be a scatter plot where the dots are kind of like this. They don't trend up or down, okay? If there is a correlation, then it's a causation. Okay? Which is also called a causal relationship. So, if you have a table of X and Y values, that is called an association. If that table makes a scatter plot that forms a correlation, a positive or negative correlation, if the Y is dependent on the X, if X makes Y happen, that is called a causation, which will be called a causal relationship. Oh, lots of new words, huh? Now then, let's go down to here. Notice this is a table of values. This table of values would be called an association, right? So a table of values is called an association. This would be the scatter plot, right? Notice that this forms a trend line going up, right? Since it forms a trend line going up, it is a causation. Okay? That means that the height impacts the age in years. Okay? That causation can also be called a causal relationship, which means that the height has an impact on the age in years, especially when you're in elementary. The older you are, the taller you are, right? Until you reach your maximum height. Okay? Now then, the trend line is the line of best fit. Okay, so in this one right here, the trend line would do something like this, right? It can't go through every dot though, can it? Okay, so you're going to pick a trend line, and notice that the dots will be equally spaced above and below the line. I just roughly drew that, okay? So you've learned a lot of new vocab on that page. The first thing you've learned is a scatter plot is also called an association, which generates usually from a table of values. So a table of values is also called an association. If the trend lines or the scatter plots form a pattern of dots going up or down, it's a positive correlation or a negative correlation, which is called a causation, which means that the y is dependent on the x. If there's no correlation, that means the scatter plot does not form a line, then it's just an association. It's not a causation, which means it will not have a causal relation. Now then, let's define these then. So an association basically is a table of x and y values okay, and it forms a scatter plot. Okay, so another word for a table of values or a scatter plot is an association. If it is a causation is an association with a correlation, with a positive or negative correlation. Okay, sorry about my handwriting. A causal relationship is an association that has a causation. This is kind of weird, okay? Another way to think of it, X makes Y happen. For instance, if you're getting paid per hour, the more hours you work, the higher your pay. That is a causal relation, okay? What about the gasoline in your car as you drive? The more miles you drive, the gas goes down, right? That would be a causal relation. One would be a positive correlation, one would be a negative correlation. But X makes Y happen. That is a causal relation. A line of best fit is a line through a scatter plot. Line through a scatter plot where the dots are evenly spaced above and below the line. We're not going to go as deep as statistics, but this basically is your statistics here. You would calculate the distance above and below each point, and you would want to make them equal. We're not going to get into the terminology of that in Algebra 1, because the TEKS says you don't have to. But that line of best fit basically is getting the distance above and below all those dots equally spaced. Interpolation is when you estimate inside the x values of a table. Okay, interpolation is when you estimate. That means you use the line of best fit, you input the number, and you estimate with that. But it has to be within your x values. We'll talk about that in a minute. Extrapolation would be when you estimate outside the x values, which basically is your domain, right, of a table. And the correlation coefficient, okay, this was in your TEK, okay? The correlation coefficient, write down R, that's the symbol used for correlation coefficient, is the strength of the scatter plot. Jiminy crickets. That means how close the dots are to the line. The closer the dots are to the line, the stronger the scatter plot. Your correlation coefficient will go from -1 to +1. The closer it is to the -1 and +1, the stronger the coefficient, or stronger the correlation. The closer to 0, the weaker the correlation. Okay, so your correlation coefficient can go from -1 to +1. If the correlation coefficient is a -1, all of the dots are on the line and the line goes down. If the correlation coefficient, we're going to talk about this tomorrow, if the correlation coefficient is a +1, the dots go up and every single dot will be exactly on the line. So -1 to +1 is a very strong correlation. Now then, write this down. The strong correlations are above 0.9 or -0.9. So if the correlation coefficient's 0.9 or greater or -0.9 or greater, it's a strong correlation. The closer it is to 0 is a weak. So like a 0.7 would be kind of like a medium correlation. Okay, so closer to 0 is weak, closer to -1 or +1, the stronger. Okay, that's the correlation coefficient. We will talk about that tomorrow, and you will use your calculator to do that. Today, you won't need a calculator. So let's continue on. A lot of new vocab here. This is basically a vocab. This basically, the next 2 days, is the statistics part of your Algebra 1. Okay, now then. This is the same set of data points, okay? So on the next page, they're talking about the same set of data points. Now then, this is how they generated the equation. And we don't have to do it because it's in the notes, which is why I pulled this up. Basically, they're saying that this line goes through this dot and this dot. Okay, so this dot right here would be the 4,40. And this dot would be the 8,50. Okay, so what they did is they drew a line of best fit and they made it to where it went through 2 of the dots. So basically they connected this dot to this dot, and notice some of the dots are above and some are below. They're not all exactly on the line, but it goes through exactly those 2 points. So what they did is they took those 2 points and they found the slope, and it's important when you're doing this, make slope a decimal. Don't make it a fraction. Your calculator is going to give the slope as a decimal, so you will not convert this to a fraction today. So when we do these calculations, we're going to leave all these with decimals, okay? So your slope is a decimal. Now then, this is a slope, and notice what they did is they took this point and this slope, and they plugged it into point slope the same way I am teaching you on it. This is why I'm teaching you to do it the way I am. This is the best way to do it. So they took the first point in the slope and plugged it in, and they made it an mx plus b, didn't they? Now then, with that mx plus b, we could predict. Notice they want to predict the height of a 12-year-old girl. Notice that 12 is up here, right? That is outside. Our smallest x is 2, and our biggest x is 10, right? This would be extrapolation. Because we are predicting outside of the 2 and the 10, right? Our domain goes from 2 to 10, doesn't it? If I were to want an 8-year-old, I would be using interpolation because I would be predicting between them, okay? If I wanted a 1-year-old, it would be extrapolation, right? So if I'm predicting between 2 and 10, it's interpolation. And if I go over this side or over here, that is extrapolation. Most of the time you will do extrapolation. You're going to go into the future, and it basically is the meat of statistics. Okay, that's like a lot of what statistics is about. They have this scatter plot, what will happen in the future. Okay, if you go into statistics, you're going to be doing a lot of that, okay? So notice, if they put 12 into x, they came up with 60 inches, didn't they? Okay, so they're using this scatter plot to make an equation to predict what's going to happen to the line. Okay? Piece of cake. Now then, do not do this, because we're going to do this tomorrow when I made the next page. Okay? So don't do any of this. Okay? Don't do any of that. We're going to do that tomorrow. This is what you need to do today. Okay? So you should try to do your best and match these up. This basically is your homework. So this is your homework for today. And do this problem and this problem. Okay? On these two problems here, you're just going to make a scatter plot and you're going to say positive or negative correlation. Now then, I'll make the scales for you. So this is X, this is Y. Okay? So our TEKS scores and our study time, right? Okay, so we're going to put test score down here. Let's switch this. Let's make our test score Y. So let's make our test score Y and our study time X. So our input will be study time, right? That's the way this graph really is. So if you input your study time, your output will be your score. So your score is going to be Y and your time will be X. Okay, and our time goes from 30 to 100, doesn't it? So we're going to start at right here and do 30, 40, 50, 60, 70, 80, 90, 100. You're just making a rough graph. Try to make these spaces the same. Then the test score is going to go from a 76 to a 97. Okay. So let's start at 70 and then do 80 and then do 90 and then do 100. And then you're going to make a rough estimate of where these dots would be. For instance, I will graph the first one for you. The first one will be 33,76. So 33.76 would be about right here, wouldn't it? So you're just going to go through and do a rough graph of where those dots would be and then write down positive or negative. On this one right here, let's make, if we buy adult tickets, will we buy children tickets? Okay, so will the number of adult tickets have an impact on the number of children tickets? So let's put adult down here for our X, that's our input, and the child tickets over here, that's our output. Okay, so this will go from 10 to 50, so I'm going to put 0 here, then 10, 20, 30, 40, 50. Try to space them equally. And now then the child tickets go from a low of 30 to a high of 147. So let's go up by 20s. So 20, 40, 60, 80, 100, 120, 140, right? Now then, you're just going to make a scatter plot with those dots. The first dot would be 30, 10. Okay, so if I start at 10 adult tickets, I'm going to go up to 30, which will be about here, and just make your scatter plot, right? Then you're going to write down a negative or a positive correlation. Okay, and then stop right there, okay? So your homework tonight is to do those two and to match up these vocab words, okay? Have a wonderful, wonderful day. Have a wonderful, wonderful day. Remember, you are amazing. You are created to do wonderful things, and you are awesome.